Okay, so this time I have this question, power of 4. And see, it is a streak question, right? If you click on this icon, this question will open for today's streak. Okay. So see, I have done a question of power of 3 in one of my previous video, but that time I don't know, I didn't read this follow-up. This follow-up says, could you solve it without any loop or recursion? Means, can you solve it without O of n? See, recursion also take O of n and loop also take O of n for this. So can you do it without that? So whenever something this like comes to us, so what we think is what is the better time complexity rather than using O of n instead of using that? What can I use? So the time complexity which comes to my mind is after O of n is O of log n. That's the best. Yes. So I think I should think O of log n, and whenever O of log n comes to us, we always think about binary search. So yes, that's our answer. And how to apply binary search for this? So see, I have taken this. Answer is 16. Suppose n is 16. I'm dry running this for n is 16. So let's take L here and R here. Okay, and I'm changing its color to purple, and I'm changing its color to wait, just a second, to blue. Yes. So see, we will start a loop, not loop, binary search. Yes. So we will found what is middle. So 16 plus 1 is 17, and 17 by 2 is 8 point something. Yes. So its whole value is 8 only, floor value. So middle will come here. Okay. So and see, middle, if you do 4 raised to the power 8, it is far greater than 16. Yes, it is far greater than 16. So R will come what? R will come where? R will come here. Yes. Now again we will find middle. So middle is what? 7 plus 1 is 8, and 8 by 2 is 4. So 4 is our middle. So go to 4. No, not go to 4. Go to 4 like this. Yes, 4. And middle will be here. Okay. So now we'll check what? See, 4 ki power 4. Yes. This time not 8. 4 raised to the power 4. 4 raised to the power 4 will always be greater than 16. So again, R is R minus, yes. So now if we calculate middle, we'll come to this 2, and that is our middle, yes. And if you calculate 4 raised to the power 2, not 4, 4 raised to the power 2, 4 raised to the power is equals to 16, not greater than. So that's our answer. Simple. Again, a very simple technique. Yes. Suppose our answer is 64. N is 64 here. Here n is given 16. But let me take for I know what is the edge case here. So suppose n is 64. Yes. Our middle is right now. N will remain same. But our middle is 2. And if you do 4 raised to the power 2, it's 16. It is less than 64. So at that case, we will move L to R. And now if we calculate middle, so yeah, our middle is giving us right output. So L plus R by 2 is middle, and if we calculate that, we'll get the right output. So let I see. And for 1, see, 4 raised to the power 0 is 1. So I'm taking L is equals to 0. Okay. And let R is equals to N. You can take n by 2 also. Your power will never exceed n by 2. But for simplicity, I'm taking this till L less than R, right? So till L less than R, and I'll calculate let M is equals to math. See, for calculating middle, we do something like this in JS, and in any other language, you can choose whatever you want to do. I'm just talking about JavaScript here. So math.floor L plus R by 2 is required here. So by 2 is also, that's how we calculate middle, yes. And there's a basic formula of calculating middle. Mat.floor is just converting that decimal to towards 0. Yes, truncating towards 0. So okay, so mat.floor L plus R by 2, yes. And now what I have to do? So if middle raised to the power 4. So for power 4, we do something like this. Is equals to, not like this, is equals to what? My n. M raised to the power 4 is equals to n. Then or 4 raised to the power m. 4 raised to the power or m. See, 4 raised to the power m. Not that, like that. 4 raised to the power m is equals to whenever it is equals to n. I am return. Just return it. So you can skip these brackets as well. Just return. Return what? Return true. Yes. Else if I'm copying this thing, I don't want to type it again and again. If this is greater than, see, when it was greater than, see, when middle was at 8, it was greater than, yes, it was greater than 4 is to power for far greater than, we are reducing our r. So if it is greater than n, then just do something like this. R is equals to m minus 1. Yes. And else L is equals to m plus 1. At one point, your L and R become equal. Yes. And at that time, see, when my L and R become equal, I would like to what? I would like to calculate middle. If it is equals to, then return it true. Else break the loop. So I can write equal to here as well, or I can do something like this. Return. See, I'm copying this L plus R. See, now L plus R will be at same place. I told you how. See, if I do like this, when our when our answer was 3, L and R will be at same place. When our n is 64, L and R will be at same place. Now I'll again calculate if is equals to n. If it is equals to 64, just return true, else false. Yes. So let's run this and see, will this run or not? So it should run. Okay, in first case it is giving me false and our output should be true. So let me see why. Uh, okay, R is at nth place. Okay, so what's the harm here? Let me see. N and R will be at same place, and that time this loop will be stop. So if it is equals to n, just return true. Equals to n. So okay, so let's take this edge case. Suppose our n is 0. Okay. I got it. What's wrong here? So suppose n is 16 and it is giving us false output. Why? Because we have taken we have taken L0. So L is 0. Yes, 0. So dry run will remain same and R that 16. That is 16. So middle is what? Middle was what? Middle came 2 when it was 1. Okay. So now middle will come 1. Okay. So this L will come at this place. Okay. I'm messing this condition now. Okay, L will come here. Okay, now I got it. So now L plus R by 2 middle. Okay, so this shouldn't give me right output. This should give me right output. Okay. I'm doing it wrong. Why? See, this is my middle. This is my middle. Okay. Now I got it. Uh, let M is equals to. I'm again calculating my middle last time. And if middle power 4, 4 is to the power middle. This was wrong. Nothing was wrong here, but this was wrong. Only if it is equals to n, return it. So this is a fingers crossed. This should give me right output. See, it is giving me, and if I submit this, this will be submitted. Yes, no error here. So all submissions. Hope I won't fall in error. I see. We didn't get any error. So day one stage completed. And if I analyze its complexity is O of log n, as I said. So if you see it, wait. It is O of log n. So again a very simple question, and this was again our approach. You can see we have three different approaches to do a same type of problem. You can, the first basic approach is a for loop. You can apply for loop and you can do this easily. While loop, we can do even apply while loop. So that's again a very good approach. So for basic, that's a good approach. And recursion is also a very good approach for this. But even better than this is even better than recursion. That's why we are doing this. This is its graph would be looking something like this. See, when I did this, its graph was like this. See, analyze complexity. Okay, graph is not shown here. So again, it's okay. Its graph is like this. Let me show you. It will be like this. If you draw it, it will be like this, something like this. I cannot draw it correctly, so that's all. So that's my solution for this. Thank you so much.